Good morning, everyone. Welcome back. So, recalling last video, we had set up 4 equations to find out b as a function of t, a as a function of s, and then eventually f, g, and eventually v. Okay, so in this video, I'm gonna go ahead and solve these 4 equations and see what we got. Okay, so let's go ahead and get started. If you notice, so from 4, so what will happen from 4? 4 is just like a basic normal differential equation, right? So if you integrate both sides, if you rearrange a bit, you get db equal to c1 times dt. Let me write better. db. Okay, and if you integrate both sides, you get b equal c1 times t plus c2. Okay, so this is where I'm confusing. Okay, but maybe later when you guys study the problems, we can find a better way. We can find a better explanation. This is where, so I look up Wikipedia and they got the boundary conditions. Okay, so in other words, they have a answer for C2 and C1, but I really don't want to understand why right now. So I'm gonna write for boundary condition reason. I don't know why. They pick C1 equal negative 1/2 and C2 equal 1/2 T. Big T, I think, is the temperature, or a constant temperature or something. Okay, so after they pick this, you plug it into your B and you get dB. You get b as a function of t equal to negative 1/2 times t plus 1/2 temperature, or big T. Okay, and also you have, remember, our dB over dt is c1, so dB over dt is negative 1/2. This will be useful later. Okay, we're gonna use this later. In fact, we just get b already, but the dB over dt is called negative 1/2. It's useful. It's a useful expression. We'll use it. Okay, so this is your b. So let's go ahead and see if we can solve for a. Okay, so this is outright from 5. Now we're gonna solve for a. So let's see what we got. From 5, you got what? You got dA over ds, all that square, times s squared over 2 equal 1/2, right? So you get what? So you get dA over ds squared equal s squared times 2 both sides, and then you take the square root, you get dA over ds equal s. So let's go ahead and rearrange a bit. Oh, my bad. This is not s squared. This is 1 over s squared. This is 1 over s. Okay, let's rearrange a bit. So dA equal to ds over s, and if you integrate both sides, equal, so you get a equal ln s plus a constant c3. Okay, so in this case, you can pick your a to be, remember, a is our choice, right? A is the one we created it. So in this case, we can pick c3 equals 0. So you can say a is ln s. Okay, this is your a, this is your b, this is your b, and this is your a. Okay, bracket in red. Okay, so after you got your a and your b, let me calculate a useful expression. So I'll calculate a useful expression. So another useful expression we use later. is the second partial derivative of a. So d squared over ds squared. This is the this is the second derivative of a with respect to s. Okay, so it will be the derivative of the first derivative. So d over ds of dA over ds. If you recall, dA over ds is just 1 over s right here. So we take the derivative of that. So we take the derivative of 1 over s with respect to s. Just do normally, chain product rule, chain rule, whatever work best for you. So you get negative 1s squared. Okay, this will be useful later. Okay, now 6 and 7 is gonna be our main equation, right? The long one. So now we have our a and our b. We can go ahead and solve for 6 and 7. You notice that in 6 and 7, let me use this highlight. They have this term, right? We have dA squared over ds squared, dA over ds, dA over ds. That's why we calculated in advance, so we just substitute in very simply, and similarly to 7. Okay, so now let's see for, we can write now we can solve for 6 and 7. So if you from 6 if you plug everything we just got in, replace the dA over ds or d squared s over d squared a over d s squared, you get partial g with respect to a times 1 over s squared times s squared over g plus 1 over s times s plus negative 1 over s squared times s squared over 2 equals 0. Okay, so let's simplify this. So you get partial g over partial a times 1 over g plus 1 minus 1/2 equals 0. So you should get partial g partial a times 1 over g plus 1/2 equals 0. So you get partial g over partial a times 1 over g equal negative 1/2. Okay, so now you get partial g over partial a equal negative g over 2. Okay, this is a useful expression, okay, for later. So that's why I want it to be this form. So let me write, this is a useful expression for later. Now we proceed to solve for g. Okay, so in order to do that, you need to rearrange in a better way. So you rearrange, you write partial g over g equal negative 1/2 over times partial a. Okay, so you notice this is like a partial differential, partial derivative. So when you integrate, instead of a constant, you get a function. Okay, so, I'll explain what does it mean when we get to that. So let's go ahead and integrate both sides. Okay, so I integrate partial g over g equal negative 1/2 integrate partial a. So you get this just like you do the integration, just like you do dg over g, partial g over g. Just some modification. So ln g equal negative 1/2 times a plus h of b. Okay, so at this point, why I didn't write c4? Why didn't I write like this, a constant c4, right? But I write h of b. Well, you ever recall that g is a function of a and b. So in this case, g will equal to a times something, negative 1/2, negative 1 over 2 times a, which is the part of a, and then the rest belong to b. So plus hb. So in this case, hb serve like a constant. So You see what I'm saying? Because the mean integral on the right hand side is partial a, so our main character here is a, and the rest belong to b, because g is a function of a and b. And the easiest way to understand this is just think about this way. HB is a generalization of a constant. Okay, HB could be a constant. It could be a function of b. We just want to make sure. We're not guaranteed that LNG is -1/2 times a plus a constant. We're not sure. We know that it could be a function depend on b as well. So that's the way we generalize it. Okay. So alright, be careful. G is a function of a and b, right? Okay, at this case you can solve for g both sides. So g, you just exponentiate both sides, so you get a plus hb. So you get a over -1/2 times a over h, a to the power of hb. Okay, so this is your g. And now we proceed to solve the boss, which is 7, right? Oh, okay, I think that's another useful equation we can calculate. Okay, that's another useful expression we can calculate. And the reason why I do all the useful calculations is this. I'll show you why. So now I found g already, right? So you notice for equation 7, we have this term, partial g over partial a, partial stress g over partial a squared. I just want to calculate that in advance, okay? I just want to calculate it. I sincerely want to calculate that in advance, okay? So let's go ahead and calculate those in advance, just like I did with this one right here. You see, I calculate partial g over partial a equal to -g over 2. Yeah, so let's go ahead and do that. So another useful expression we can calculate. So let's go ahead and do that. So it's the partial g, second partial of g with respect to a. So it's just the partial of the first partial. So partial with respect to a of partial g over partial a. Right, you understand this? It's just this. It's basically say the second partial derivative is the partial derivative of the first partial derivative. Okay, so we already have, now just plug it in, partial g over partial a we already have is g over 2, right? Yeah, -g over 2. So now we just go ahead and put -1/2 out, so it's just partial g over partial a. Partial g over partial a, we have that. We know it's -g over 2, so we just keep on replacing. So we get g over 4. Oh, I totally forgot to label the number's name. Okay, 6, 7. Just want to keep track with everything here. Okay, let's call this number 8, equation 8. Let's call this equation 9. Okay, so yeah, you see this is some sort of like kind of magic, right? You do a lot of transformation, but yeah, this will be very, very useful later. Okay, so we got that. Now we're ready to solve for 7. You substitute 8 and 9 into, by substituting 8 and 9 into 7. Okay, so I'll write, now we can substitute 8, let me do this, 8 and 9 into 7. Okay, so what we get? So from 7, we get partial g with respect to b times negative 1/2 times 1 over g plus g over 4 times 1 over s squared times s squared over 2g plus negative g over 2 times negative 1 over s squared times s squared over 2g plus negative g over 2 times 1 over s times s over g minus 1 equals 0. Okay, so let's go ahead and simplify this expression. So let's see. So we get partial g with respect to b times negative 1 over 2g, okay, plus 1 over 8 plus 1 over 4 minus 1 over 2 minus 1 equal 0. Okay, so you get partial g over partial b times negative 1/2 1 over 2g equal to, if you put everything left to the right hand side, you get 1 over 2 plus 1 minus 1 over 8 minus 1 over 4, which is 8 is a common denominator, so this is 4 plus 8 minus 1 minus 2, so this is 9 over 8. Okay, very beautiful. If you get after that, you can do some even further rearrangement. So you times both sides by negative 2g, you get partial g over partial b equal to 9 over 8 times negative 2g over 1, which is negative 9 over 4g. Okay, I will call this equation, what? Equation 10. Okay, what are we gonna do after this point? Recall. This is what you need to recall. We got g already. Y'all remember? We got g here. This is we got g. So it's e to the power of negative 1 over 2 times a times e to the power hb, right? So recall g equal to e to the negative power of negative 1 over 2a times e to the power hb. So you take the partial of g with respect to b, you get negative 1 over 2a, just like a constant, so you didn't do anything. hb, now you just take the derivative of hb, so times partial with respect to b of e to the power hb. So this would be normal derivative, right? Because why I'm doing this, why I'm converting from partial to ordinary derivative, because e to the power hb is just a function of b. Okay, you see what I'm saying? So there's no partial derivative of b. The partial derivative of b is also the full derivative, because e of hb is completely belongs to b, completely. Okay, you see what I'm saying? So you just do normally. So this just e to the power negative 2 over a, e to the power negative 1 over 2 times a. What's the derivative of a function of e to the power? Recall that if you do this, d over dt of e to the power of t, it's just et times d oh, this is a bad example. Let me give you something better. So let's say if you do derivative of this of, let's say, f, so you get e to the power f times df over dt, right? This is the derivative law for the exponential function. So you apply that, you get e to the power negative hb times h prime b. Okay. So now you got the partial g with respect to b. You can plug back into 1. So to 10, sorry. Substitute into 10. So if you substitute to 10, you get partial g with respect to b, you replace with all this. So you get e to the power negative 1 over 2 times e to the power hb times h prime b equal to what? Equal to negative 9 over 4 times chi. And you recall what's chi, right? Chi is just 9 over 4 times chi is just e to the power of negative 1 half times a times e to the power hb. Okay, it's from here, the one I highlight in yellow. Okay, so let me rewrite the expression. So you had e to the power negative 1 over 2a times e to the power h to the power b times h prime b equal to negative 9 over 4 times e to the power negative 1 over 2 times e to the power hb. Okay, so for this side, what can be cancelled out? This term can be cancelled out. This term can be cancelled out. And you get h prime of b equal to negative 9 over 4. So h of b basically it's just saying dh over db equal negative 1 9 over 4. So so what's our hb is just negative 9 over 4 times b. I pick c as equal to 0. Okay, you don't need c in this case, you can choose. So what's our chi as a function of a and b? In conclusion, chi is e to the power of negative 1 over 2 times e to the power hb, right? So now you have hb already, so it's just e to the power negative 1 over 2 times a times e to the power of negative 9 over 4 times b. And if you want to make it look better, just add them up. So negative over 2a minus 9 over 4b. Okay, so we got our chi. That's it. That is exactly what we're looking for. This is our chi. So basically now what's happened, let me recap. Okay, so now our v, you remember our original goal. Our v is f times chi, right? And if chi is that form, we can reduce it to equation 3. Okay, so now let me try to recap everything. So now v as a function xt will be equal to f a b times chi a b, right? Which chi a b is just chi a b equal f a b times e to the power negative 1 half over a minus 9 over 4 b, right? Where a is a function of s, so a is ln of s. B is a function of t, so negative 1 half t plus 1 over 2 times a big constant t. Okay, so when you solve for this equation, you're gonna start where? When you, let's say you plot this graph, right? So let's say the first thing you're gonna do is you will solve for f. So how do you solve the equation? Now, what is the train of thought? The train of thought. So we know that by substituting like this, by saying v equal to f times e to the power whatever, you got reduced to this equation, right? Where is it? There you go. See what I'm saying? So we get reduced to this equation. Now let me go ahead and, can I copy paste that? Let me try. I think I can. Where's that? There we go. This expression. Okay. Copy. Let me go here. Oh, we did a lot of math, actually. You see? All right. Let me insert text mode and then put here. Control V. Wonderful. Okay. So we start with this equation, right? You got f as a function of a and b. After this, you might need to convert the boundary condition too. So the already boundary condition is in s and t. You convert it to in a and b, okay? Because remember, a is L and S and b is yeah. Let me do this. So boundary condition, so you have st, if you substitute, and if the same for the second boundary condition, st, you do some transformation. So a is L and S, b is -1/2 t plus -1/2 big T. A is L and S, b is -1/2 t plus 1/2 big T. You get the first boundary condition as AB, second boundary condition as AB. Okay, after you solve this equation, you get f as a function of a and b. Okay, so and then after you get f as a function of a and b, you get, you say v st is a function of t ab times f ab, and then you get v s of t. Okay, you see what I'm saying? So this is, let's demonstrate in Excel. It's easier. So this is what you're gonna do in Excel. Okay, so you have a bunch of s and a bunch of t at first. Okay, you just, it's like 1 0 0 1 2 second to, let's say 1000, similar with t 1000. Then what you're gonna do is you calculate a as a function of s. A is L and S, so you got all the a, and then you calculate the b as a function of t. So -1t plus 1/2 t. You get all of this, right? And then you plot f. You plot f. And then you plot g as a function of a and b. And then lastly but not least, you're gonna plot v. Now it's a function of s and t. Okay, it just times fab times gab. Okay, so this column is our main output, the main input, and this column is the output. Okay, does it, hopefully it makes sense for everyone. This is the train of thought. Okay, so if you read the textbook, you notice they do a very interesting substitution, right? The substitution you can start from now on, or in the textbook, I notice they start, is that instead of saying v equal f times g, okay, and then we find g, just like we did manually, step by step, you can start with, you can also start the problem with what? With f v x s t equal f a b times e to the power of alpha a number alpha times A plus a number beta times B. Okay, this is instead of just a random function g like what we did and solve for g. Now you can say that function has the exponential form, and this is where you can start from. Okay, can start like this to reduce computation time. Okay, and that's it for this video, everyone. I really appreciate your time and patience. I know it's a long problem, so everyone, go, talk to the one you love and be proud of yourself. You just sit through very long sections. Go drink some water. Getting hydrated is very important. And remember that each of you is a shining star. You have your own path, and that path, whatever it takes, is equally beautiful and meaningful. Okay? Thank you, everyone. I hope you have a good day and night, and I will see you in the next video.